Absolute legends. We're going to draw Lewis dot structures of small molecules. We do this in 3 steps. You can find examples that have more steps, but for beginning Gen Chem, with these small molecules that contain 4 or 5 atoms, these 3 steps cover a lot of situations here. Note that it's important that steps 1 and 3 are fulfilled for a good structure. And what this loop here means is that we cycle through these 3 steps following them until points 1 and 2 are complete. Today, we're going to draw this molecule here, cyanide, Cn with a -1 charge. To get our total electron count, we are interested in the electrons that are available for bonding that carbon and nitrogen have. So carbon and nitrogen, we're going to find them on our periodic table and think about the valence electrons that they contain. Boron, carbon. So carbon has 6 electrons total, but only 4 of them are used for bonding because there are 4 in the valence shell. So carbon brings 4 electrons to the buffet. Nitrogen, here is, oops, look that up. Boron, carbon, nitrogen. Nitrogen has 7 electrons total, but only 5 are in the valence shell. So nitrogen brings 5 to the buffet. Now this molecule has a -1 charge. So anything in the universe that has a negative charge means that it has gained an electron. So we're going to add 1 electron to our sum here. 4 plus 5 plus 1, 10 electrons. Our final structure can have no more or no less than 10 electrons. It's got to have that right there. Note that this is an even number for a lot of Gen Chem examples. If you get an odd number, you might be drawing what's called a radical, and you should be told that you're drawing a radical or something like that to get that if you have an odd number of electrons there. So we're going to draw 1 bond and 1 bond only in between these elements here. We only have 2 elements to play with, so we're just going to have carbon and 1 bond to nitrogen there. And those 2 electrons, those 2 dots representing the 1 bond in between the atoms there. So those electrons representing the glue. Step 3 is checking the octets. So right now, carbon doesn't have an octet. It needs more electrons. So for our first guess, let's keep it simple and predict that there's 1 bond in between them. And now this carbon has an octet. And let's do the same over here. Let's fill in the octet for this atom. So our first guess, there's 1 bond in between them, keeping it simple. And everybody has an octet. Let's make sure that we have 10 electrons, no more, no less. We have more than 10 electrons. We have 14 electrons on here. So what do? We keep cycling. We have too many electrons. 4, F-O-U-R, many electrons. Only make 1 bond in between the atoms. Now don't get tempted and get ambitious and try to make 2 or 3 or 4 electron bonds right off the bat. Just keep it simple, keep it slow. This isn't a race. So my next guess, my next simple prediction is going to be 2 bonds in between the carbon and nitrogen. Don't think that, what the hell are you doing? You added more electrons, all right? We can erase, don't forget that. After adding another bond in between them, 1 more bond, I'm going to edit my prediction by checking my octets. This nitrogen over here now has 4, 5, 6, 7, 8. It's got too many electrons. So I'm just going to erase these 2 electrons here. So now this has an octet. This carbon over here has 4, 5, 6, 7, 8, 9, 10. It also has too many electrons, TWO, many electrons. So I'm going to erase those 2 electrons right there. Carbon and nitrogen both have octets. So now I'm going to make sure that I only have 10 and 10 only in this picture. Okay, I have TWO many. I'm going to keep working through my loop here. I'm going to make one more bond in between them. Only one bond at a time because this isn't a race. Now I'm going to check my octets again. 6, 7, 8, 9, 10. I'm going to erase 2 more. So now this nitrogen has an octet. This carbon here, I can erase TWO of them. So now this carbon has an octet. And now to make sure that this number matches this number, it does. So this is a good Lewis dot structure because everybody has an octet, and we're only allowed to have 10 electrons, no more, no less. That's kind of the topper on this. You could put this in square brackets, put a -1 to tell the reader that this thing overall has a -1 charge. Thank you.